100 feet from the liftoff point. At the moment the rangefinder's elevation angle is pi/4, the angle is increasing at the rate of 0.14 radians per minute. How fast is the balloon rising at that very moment? So draw a little picture, see how good you guys are drawing pictures. So we have our balloon, and coming down from our balloon, and then we have our nice little basket, and our balloon is lifting straight off. And then 500 feet away over here is your rangefinder, and he's 500 feet. Notice that it does tell you that it is rising straight up, which does give us a 90-degree angle here. But the reason this one is trig and not Pythagorean is because we don't have a side here, but they do give us an angle of elevation. So the rangefinder's angle of elevation to the balloon here is pi/4. Now, one thing we do have is this is a SOHCAHTOA thing. So you do have at least that SOHCAHTOA idea. So we're going to assign variables. So I'm going to let x equal the height of the balloon. I'm going to let y equal the distance of rangefinder, is it called a rangefinder? Yep, rangefinder from the liftoff point. And then theta is your angle of elevation. So at this moment, we can also identify, we can go, well, let's go ahead and assign values. X equals, we don't know. Dx dt, how fast is the balloon rising? That's what we're looking for. This is what we're looking for, so we definitely need this value. Y is equal to the distance from the, anyways, it's this distance here, which is 500 feet, I believe, 500 feet. So dy dt is 0. It doesn't change. The balloon is going straight up, and the rangefinder is not moving. So that distance will never change. And then theta, we have pi/4, and d theta dt is equal to 0.14 radians. Now, the question is, how fast is this thing going up? So we need a formula, like I said, because we have a right angle, we can use SOHCAHTOA on this thing. And so we don't need to know this value here, but we do need to know the height of the balloon. At this particular time, how high is the balloon? A lot of you guys are going to figure this one out very, very quickly, but I'm going to go ahead and do the math. I don't need the hypotenuse, which directs me straight to tangent. So tangent of theta is going to be opposite over adjacent. And you can also identify these as being the opposite and adjacent, because this is the height. So tangent of pi/4 is equal to the opposite, which I don't know, over the y value of 500, the adjacent. This is going to give me 1. Tangent of pi/4 is 1. 1 equals x over 500. We know x has to be 500 as well. Now, if you're going, well, I knew this. Well, yeah, because if I would have thought about it before I started doing the math, and we have a right angle, we have an angle of elevation of 45 degrees, which means the other angle is 45 degrees, which means the two sides are congruent. But no, we have it. So we got our missing information. So step 1's done, step 2 is done. We have our equation. There's step 3. I guess I'll label it step 1, step 2. Step 3 is our equation that we need. Here is our values. So now we're ready to do the derivative. So step 5. Tangent of theta equals x over y. So x over y, but y is 500. Because when I do the derivative, it's going to be 0 anyway, so we don't have to worry about it. We can get to plug that number in. So do the derivative at this point here. Tangent of theta gives us secant squared. So we get secant squared of theta d theta dt equals derivative of x is 1, so this is going to be 1 over 500 dx dt. Now, for those of you who are going, why didn't the 500 go away or whatever kind of thing? Well, this is, again, it's a constant. I have that value of x being multiplied by 1 over 500. Take the derivative of x, multiply it by the constant that was there to begin with. Now, if I hadn't put the x in there, I would have had to use quotient rule. Anyways, if I hadn't put the 500 in there, we would have had to use the quotient rule, and then we would have seen where it would have disappeared and what have you. Okay, so we're ready for steps 6 and 7. 6 is substituting, 7 is solving. So I have secant squared of pi over 4 d theta dt, which is 0.14, equals 1 over 500 dx dt. That's what we're looking for. So pi over 4 secant is the reciprocal of cosine. Cosine of pi over 4 is radical 2 over 2, so the reciprocal will be radical 2. So we get radical 2 squared times 0.14. So this is going to be 2 times 0.14 or 0.28 equals 1 over 500 dx dt. Multiply both sides by 500, and we get dx dt is equal to 140. And our measurement is going to be feet per minute, because that's how they're measuring it. The height is 140 feet, and it's in minutes. So for those of you guys going, wait, this is in radians. That's still an angle. We're not measuring the angle, we're measuring height. So 8. The balloon is rising. At a rate of 140 feet per minute when angle of elevation when theta is equal to pi over 4. There you go. That's how quickly the balloon is rising. Okay, so now the next problem is a similar problem as such, but we're going to find that this one is not going to give us the angle. So there are ways of approaching this one when they don't give you an angle, but we'll go through it. So on a morning of a day when the sun will pass directly overhead, the shadow of an 80-foot building on level ground is 60 feet long. At the moment in question, the angle theta the sun makes with the ground is increasing at a rate of 0.27 degrees per minute. At what rate is the shadow length decreasing? Express your answer in inches per minute to the nearest tenth. Remember to use radians. You guys, it doesn't matter if they give you degrees in the problem. When you're calculating, you have to use radians. So, step 1, let's draw that picture. So I have an 80-foot building. You guys are not going to get nice pictures out of me. But this building is 80 feet tall. And it has a shadow over here, la 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 la, of 60 feet. I know the shadow looks longer than, anyways. Nice little sun over here. And we get an angle of elevation. Angle of elevation of theta here. They did not tell us what the theta is, but they do tell us how quickly it is changing. So there's two ways we can approach this problem. We can use trig. Either way, we're going to have to use trig, but we can use trig to find the angle, or we can use SOHCAHTOA to find the missing value. I'm going to approach it using SOHCAHTOA. We'll still have to do the trig, but we won't have to mess with angles per se, which will make it a really nasty problem, by the way. So assign variables. X is going to be the height of the building. Y is going to be the length of the shadow. Theta is your angle of elevation. And I'm going to throw Z in here. Z is the point of the angle, point on ground, to top of building. We're going to use SOHCAHTOA. We're still using SOHCAHTOA on this one. We do need the angle. So let's go ahead and assign values. That way we know how to approach this. X is going to be 80 feet. Dx dt is equal to 0 because the height of the building is not changing. Y is going to be 60 feet. And dy dt is what they're asking us for. They asked you to express at what rate is the shadow length decreasing. Theta is we don't know, and d theta dt, they do tell us, is 0.27 degrees. That is 0.2727 pi over 180. And that gives us a nice decimal value of 0.0015 pi. And then Z, we don't know, but we can get. And dz dt, we don't know, and we're not really going to need it. Okay, so we don't know this one and we don't know this one, but we really don't need, because we're not going to be using them. We're going to be using tangent on this, but it's when we get ready to solve that we'll need this guy. So I'm going to use Pythagorean. So this one's kind of a mix of the two. I'm going to go ahead and use Pythagorean. X squared plus y squared equals z squared. So 80 squared plus 60 squared equals z squared. And you put this into the, I guess I can do this, 6,400 plus 3,600 is going to give you z squared. This is going to give you 1,0,0,0 equals z squared. So z is going to equal 100. By the way, I could have taken this down because it's a 3, 4, 5 triangle, just calculated what would be multiplied by. And I could have gotten to my 100 that way. So there you guys go on that one. So my z value is 100. Now, for those of you guys going, wait, I'm just totally lost at this point. I'm not going to find the angle on purpose, because I don't need the angle. I'm just going to need trig values of the angle. So I'm using SOHCAHTOA. So I use Pythagorean to find the three sides of the angle, the triangle. The actual, so this is step 1. Step 2, I always claim this to be step 4 to find your, to assign values. Step 3, the the equation we're going to use is tangent. Tangent of theta equals opposite over adjacent. So in this case, tangent of theta is equal to x over y. And before we do the derivative, we do want to plug in what is a constant value, and our constant value is the height of the building, which is x. So tangent of theta equals 80 over y. Okay. So we're ready for our derivative. Step 5, derivative. Derivative tangent is secant of theta is equal, and this is really 80 to the y to the -1. So this is going to give us negative 80 over y squared is what we're going to get out of that. Because 80 times y to the -1 power is going to give us negative 80 y to the -2, which puts y squared in the bottom. So we're ready to substitute values that we know. We don't know what theta is, but we can figure out secant. Secant is a so this is a lot of side work over here. Secant is cosine. So I'm going to write secant of theta is equal to 1 over cosine of theta. Well, cosine would be adjacent over hypotenuse. So secant is hypotenuse over adjacent. Okay, so secant of theta, if we come up here, the hypotenuse is 100 and the adjacent side is 60. So this is 100 over 60. Yes, I do realize I forgot d theta dt. d theta dt. This is dy dt. That is a common mistake that you will make. I might as well state it. Obviously, this is the second time I've forgotten to put the d theta part in. So please don't forget about that. That you cannot forget to do the d theta dt kind of thing. My d theta dt is 0.0015 pi. We can come up here so you guys can look at that going, oh yeah, there it is. Equals negative 80 over y squared, which is 60, dy dt. dy dt is what we're looking for. How quickly is my angle decreasing? So calculator time, we got a lot of calculator thing here to do, but I'm going to go ahead and move things around. I'm going to multiply by 60 squared over negative 80 on both sides. So we have 60 times 100 over negative 80. And for those of you going, wait, what happened? I have two 60s here. I canceled one of them out on the top. Times 0.0015 pi equals dy dt. Okay, so I'm going to just put this into the calculator and get a value back on it. 60 times 100 divided by negative 80 gives me negative 75. Multiply that by 0.0015 pi. And we're going to get negative 0.3534291735. This is what dy dt equals. However, we got to pay attention to units. Everything we did was in feet. And if you go back and read the question, they asked you to do it in inches. And I will be honest, if I would remembered that, I would remembered it was inches per minute, then I would have gone in and I would have changed all of these guys to inches to make our life easier. But it's not that big a deal. You're going to take this big old number, multiply it by 12 because it's feet, and there are 12 feet, 12 inches in 1 foot, so you just multiply by 12. And I got a wrong answer. Okay, I did something wrong. Hold on. I'm going to pause. Okay, found my mistake. So I'm going to change into a green pen. That way I can show you where I made my mistakes instead of erasing everything. That way you guys don't have to erase either. I do apologize for this. And you guys probably caught it. And if, well, in class, it would have got caught. The derivative tangent is secant squared. Secant squared, which means that this guy is squared. This guy is squared. This guy is squared. And this guy no longer is there because the squares would have canceled out. So I'm left with 100 over negative 80. This is the number. That's the only thing you have to really cancel out is the number that we got right there. So 100 squared divided by 80 is 125. Multiply it by the 0.0015 pi. We get negative 0.5890486, yada, yada, yada. And if I take this guy and multiply him by 12, we get dy dt equals negative 7.06. I do apologize for that. One of those things that should have been caught a little bit sooner. So I have my value. We're ready to do this. By the way, for those of you guys going, wait. Step 6, substitute, and then step 7 is to solve. So the shadow is decreasing. At a rate of negative 7.1, they said to the nearest inch, or nearest tenth of an inch, inches per minute at time of question, at that moment. Usually you want to identify what that moment is. So you could have wrote down that when the at the time of the shadow is 60 inches, it's decreasing at 7.1 inches. Oh, I don't have to put the negative on there. Decreasing implies that this is negative. So really that negative didn't need to be there. I was just copying the thing down. All right, so that's day 2 and still 23 minutes. These do take time, and it doesn't help that I make mistakes, but it does take time. So hopefully you guys are kind of bear with me there on this one a little bit. All right, so good luck on working out some of these problems as well.